press the bell icon on the YouTube app and never miss another update.
Hello dear students, let me continue part 6 from work, power, energy. Okay, and we know so far I covered work, and in the last class we covered some energy, and of course the last one is conservation of energy in case of a freely falling body, and we know conservative force and non-conservative force. What are conservative forces? If work done by a net force, or if the total work done by the force is 0 in a closed path, then the force is said to be conservative force. And the example for conservative force is gravitational force, electrostatic force, and spring force. And we know non-conservative force. If the work done by a force is not equal to 0, then the force is said to be non-conservative force. Okay. Example we given frictional force and viscous force. Okay. And after that we derived law of conservation of energy in case of a freely falling body. Anyhow, in a freely falling body case, we got the total potential energy at the highest point, which is converted into total kinetic energy. But the total energy is in the form of mgh, and that is constant at each and every point. I consider some A, B, C, I got the same. Total energy at A, B, C is same. That means law of conservation of energy verified. Anyhow, you know the statement, energy neither be created. Statement of law of conservation of energy, energy neither be created nor be destroyed, but it can be converted into one form to another form, and the total energy of the universe remains constant. So this we covered in the last class. Now let me continue in the part 6 lecture. Let me cover motion of a body in vertical circle, circular motion. Okay, actually there are two different circular motions. Okay, that is a special concept, circular motion, for entrances. Right now I am going to cover vertical circle with non-uniform speed, okay, based on NCERT and some extra things. Okay, see, there are two types of circular motions: circular motion with uniform speed and circular motion with non-uniform speed. And there is a horizontal circular motion and there is a vertical circular motion. Okay, from now work energy power, let me continue vertical circular motion with non-uniform speed. Write down the heading, motion of a body in a vertical circle. So write down the heading. So useful to solve problems. Okay, formulas are useful to solve some problems. Motion of a body along a vertical circle, along a vertical circle with non-uniform speed. Okay, mention in brackets, with non-uniform speed. Non-uniform speed. Okay, let me show few relations in a vertical circle. Okay, there are horizontal circle, vertical circle. Okay, here let me show some relations. Okay, so here they given motion of a body along a vertical circle with non-uniform speed. Non-uniform speed means different speeds. Okay, uniform speed means same speed at every point on vertical circle. So consider a stone. Okay, take a stone. Connect the stone to the thread. Okay, take a body whose mass is m, connect to the wire and hold the wire in your hand and rotate like this, in this manner. Rotate in this direction. If you rotate in this manner, that is a horizontal circle. Now you rotate in vertical, perpendicular to you, like this. Then once the stone moves from this end to this end, what about the velocity of the stone? Decreases. If it moves to here, decreases and becomes 0. Again, once it comes down, increases. So the speed of the stone is different at different places. Okay, so just you take a body of mass m connected to the string, and other end of the string just you hold in your hand and rotate in a vertical manner, rotate like this, so that the body will rotate along the circumference of vertical circle. Once the stone is rotating or the body is rotating, then velocity of the body at this point, at this point, at this, everywhere is different. Let me find what is the velocity of the body when the body is at the lowest point, when the body is at here, when the body is at highest point, when the body is at this place by making something angle, at here, at here, at here, everywhere we can find speed of the body. Okay, that is our target of this topic. Okay, use these formulas to solve some problems. Okay, generally this concept is useful to solve the problems, especially for problems. Now let me consider a stone and see that is rotated like this. Stone or a body here, just I am holding the wire like this. Let us suppose something point O and a stone is here. Stone or a body, any point mass, okay, any mass. Okay, whose mass? See, this is mass m. From here to here, let me consider r, radius, length of the wire, radius. Now this is rotated in this direction or in this direction, anyone. Let us suppose it is rotated like this in this vertical circle. At this point, this body will have velocity. Okay, this body will have velocity. If you draw the tangent, then the tangent at this point gives the velocity of the body at this point. Let me take this point as something capital A. Capital A. If I draw a tangent, then that tangent gives the velocity of the body at this point. If I draw the tangent, this tangent gives the velocity of the body. Let me draw the tangent. This is the tangent. Let us suppose V1 is the velocity or speed of the body at point A. V1 is the speed of the body at point A. Once it comes like this, let us suppose I am choosing one more point here. Okay. Let us suppose the point name is, let me call it as B. Clear? B is clear? Okay. Here if I draw the tangent and this tangent is like this, tangent, you know how to draw the tangent. Let us suppose V2 is the speed of the body at the highest point B. V2 is the speed of the body at the highest point D. V1 is the speed of the body at the lowest point. Let me find first V1, V2. Next I can find everywhere. Here we can find, here we can find, everywhere we can find. Once we know something angle, we can find at each and every point. Now let me follow the easy way. Okay. A, B. Here anyhow, at point A, the weight of the body acts vertically downward. Weight of the body acts vertically downwards. And because of this velocity, some force is acting away from the center. What type of force is acting away from the center? Centrifugal force. So at this point, weight is acting. Okay, weight of the body is acting, and also one more force is acting. That force is m v1 square, mv square by r, m v1 square by r. So total how many forces are acting at the lowest point? mg is acting down, m v1 square also acting away from the center of the circle. So two forces are acting at this point. And in the wire, some stretching force is developed. The stretching force developed in the wire, nothing but a tension. So the tension acts towards the point O. I think you know how to decide the direction of the tension. Tension always acts away from the body with respect to that body. Tension always acts away from the body with respect to that body. So this is the body. Tension will act away from this body. That means this is the tension. Clear? Now see, at point A, some number of forces are acting. Let us see how many forces are acting at point A. At A, just you see, tension is acting upwards, mg acting downwards, mv1 square by r acting downwards. Got it? Tension upward from A, mg mv1 square by r downwards. Therefore just you balance it. Upward force we can balance it by downward force, mg plus mv1 square by r. Keep this as something equation 1. So this is the tension at lowest point. In a problem, if the given mass, if the given speed of the body at the lowest point is something 5 meter per second, then radius is something 1 meter, we can find the tension in the string by using this formula. Okay, basic thing. This is also the basic thing, very basic. Okay. Now coming to the B. At B, weight of the body acts always vertically downwards. Weight of the body acts vertically downward, and centrifugal force acts away from the body. Okay, once you leave this, the body will go off. That means everywhere centrifugal force will act. This centrifugal force is mv2 square by r. Centrifugal force is away. Once you leave this string, the stone will move away. Okay, if you leave this, it will go away. Means at every point the body experiences centrifugal force. And see the tension. Tension is away from the body with respect to this body. So away means this T2. Got the tension? Okay, with respect to you towards the O. T1, T2. Okay. Now write some equations at B. At B, how many are upward, how many are downward? Upward is mv2 square by r, downward is T2 plus mg. Upward is mv2 square by r, T2 and mg are downward. And observe here one thing. Once the body rotating in vertical circle, observe the tension in the string when the body is at the lowest point and when the body is at the highest point. Observe the stretching force developed when the body is at the lowest point. If the body is at the lowest point, wire will stretch more. General thing. Once you rotate like this, if the body is at the lowest point, stretching force will be more. Once it come to the top, is the wire will stretch? Is any stretching force developed in the wire? Just you rotate a body in vertical circle. If it is here, stretching force is more because of the weight. Once it move to the top, gravitational force is acting down, then is the wire will stretch more? No. So almost stretching force developed in the wire is zero, negligible. So at the highest point, at the highest point, at B indirectly, at highest point, stretching force developed in the wire is negligible. So I can write T2 is negligible. I am writing approximately. T2 is negligible. If you write T2 negligible, then tell me m v2 square by r, which is equal to mg. Then what is v2? v2 is equal to, I am getting root gr. So this much speed is needed at the top. The body will have root g times of r, root of gr. So what is this? This is the speed of the body at the highest point. So speed of the body at the highest point. Once the stone is rotated or a body rotated in vertical circle, at the highest point, the body have root gr speed. Okay, root gr speed. Now let us find at the lowest point how much the speed will have. Okay, now let me find at A. Okay, To find at A, okay, now anyhow we know speed of the body at B. Target is to find at A. Next maybe they may ask here, they may ask here, everywhere they can ask. To find at A, simply just to use conservation of energy principle. Okay, because at one point if you know the velocity, to get the velocity at the other point, just you apply conservation of energy principle at those 2 points. So here right now I am having only 2 points, A and B. There is no confusion at all. So I am using from law of conservation of energy, from law of conservation of energy, let me apply total energy at point A. I am going to balance with total energy at point B. Because at B I know the velocity, that's why I am taking total energy I am going to balance with total energy at A. Okay. This is also R. This is also R. Total energy at A, nothing but it is the combination of potential energy at A, kinetic energy at A. And at B also the same, potential energy at B, kinetic energy at B. Total energy at A, let me write potential. What is the potential energy? Okay, let me write potential energy at A. Potential energy at A, okay, let me write as a potential energy plus kinetic energy at A, which is equal to potential energy plus kinetic energy at B. Okay, what is the potential energy at A? The body is almost ground, okay, so this is 0. Kinetic energy at A, kinetic energy is very clear, half m v1 square. Half m v1 square, m is the body, v1 is the speed. Coming to P, body is coming from A to the B. What height it is going to cover? R plus R. 2R height is covering now. At B, the body is at a height of 2R from A. From here to here is R, here to here is R. Total height, how much it is covered now? 2R. So, potential energy at B, we can write it as mg 2R. Got it? mg 2R. Kinetic energy, very clear, half m v2 square. M you can strike off everywhere. Okay, 2 not possible. So, half v1 square 2gr plus half, what is v2? V2 is root gr, v2 square gr. V2 is root gr from equation 1. V2 is gr. So, gr. From where? From equation 1. Therefore, half v1 square, this is 4gr plus gr by 2. Now v1 which is equivalent to 2, 4gr, gr, 5gr, 5gr. So, root. How much I am getting? Velocity of the speed of the body at the lowest point. How much I am getting now? Root 5gr. So, here you have to give minimum of root 5gr so that the body will reach to the top. And at the top, how much the velocity will be there minimum? Root gr. I will give some conditions. So, this is the velocity of the body at lowest point. For suppose if they ask to find velocity at this point. So, you write up to here, I will continue here. You continue. I got velocity at the highest point, velocity at the lowest point. If they ask velocity at the point C something, this is some point C, point D, E, F, everywhere. Okay. If they ask here, you can take some angle theta. First you take this. Okay, completed. Now let me rub this part. Yeah. So let me rub this. Yeah, here I am rubbing now. Okay. Now see, next target is to find out velocity at something other point. At C, D, E, F, everywhere we can find. So let me find at C. Now the particle is at here. Let us see how much the velocity, how much the speed that particle will have. Okay. Anyhow, weight of this particle is always vertically downward. Weight is always everywhere. Weight of the body always acts vertically downwards. If you draw the tangent, this tangent gives speed of the body at that point. Okay. And what is this? What type of force is acting away from the center of circle? What type of force is acting away from the center of circle? Centrifugal force. How much is that? mv3 square by r. Target is to find out v3. So let me find velocity at horizontal, velocity at C. Let me find velocity at point C. We can find D everywhere at point C. At point C, just let us balance total energy at A, you can balance with total energy at C. Okay, you can use total energy at B balanced by total energy at C, because at B we know the velocity. Otherwise you can balance with A and C, anyone. Total energy at A, potential energy is 0 plus kinetic energy half m v1 square. Total energy at C. Total energy at C. At C, the body is at a height of r. The body is at a height of r. Then how much the potential energy? How much the potential energy? mgr plus kinetic energy half mv3 square. Half mv3 square. Mass you can strike off it. Then half v1 we got it. How much v1? How much v1 we got? 5gr. This is gr. Half v3 square. v1 square is 5gr. v1 is root 5gr. So 1 by 2 directly we can write 5gr. Okay, minus gr is equals to half v3 square. So this is 3gr by 2 half v3 square. So 2 cancelled. What is v3? Root of 3gr. So I got velocity at point C. How much I am getting? Root 3gr. So this is the velocity at point C. Velocity at point C. Okay. Now see some conditions. Okay, you write later. Just you see some conditions. If velocity of the body is greater than or equal to root gr, tell me what happened now here. Then the body completes vertical circle or not? Then the body, so velocity, this is what v at b, v2. What is v2 value? Root gr. If v2 is greater than or equal to root gr, then no doubt the body completes the loop. Okay, completes the vertical circle. Completes the vertical circle. Okay. So if v2 greater than or equal to root gr, definitely the body will complete the circle. Means downside v1 must be root 5gr. Okay, otherwise it may reach to the top or not, we don't know. So one more condition is important. If here V2 greater than or equal to root GR and V1 is root 5 GR, otherwise it's not possible, keep in mind. So if V1 is greater than root 2 GR and less than root 5 GR, what will happen? Yeah, actually to complete the vertical circle, how much V1? V1 definitely root 5 GR for first condition. V1 definitely root 5 GR. It is greater than root 5 GR, greater than or equal to 5 GR. Now V1 value is less than, greater than root 2 GR, but less than root 5 GR. Now you expect it. Okay, condition for vertical looping is very clear. At the highest point, definitely root GR should be there. Means it is greater than or equal to root GR. Downside, it must be root of 5 GR. Now what I given is, downside is root 5 GR, but what I given, V1 which is less than root 3 GR, greater than root 2 GR, but less than root 5 GR. If V1 at the bottom is root 5 GR, then the particle completes the vertical circle. If it is at the bottom is root 5 GR, then particle completes the looping, completes the vertical circle. But what I given is V1 value, it is greater than root 2 GR, less than root 5 GR. Less than root 5 GR means maximum chance is 4 GR there is a chance. Means is the particle covers the C? Yes, definitely this particle, okay, this is the vertical circle. Particle start here and covers here. Why? Because and next it comes like this. Means it follows some parabolic path. Okay, it follows some parabolic path. So here in this situation, then particle does not completes the vertical circle. Okay, V1 I am writing, keep in mind, not V2. Particle does not complete vertical circle, does not complete vertical circle, but it follows a parabolic path. Keep in mind, parabolic path. If it is 5 GR, yes, it crosses the C and reaches the B, maybe completes the vertical circle if at the highest point is root GR is there. Okay, so now I am writing only V1. If V1 is greater than root 2 GR, less than 5 GR, means 3 GR chance is there. 3 GR means this particle crosses up to here. At what is the speed at here? Root 3 GR. If it is 4 GR here, but less than 5 GR, so the body reaches C and next it loops like this. It follows some parabolic path. Keep in mind, it follows the parabolic path. Conditions are very clear. To complete vertical circle, downside is root 5 GR, at the top is root GR. That is clear. If V1 is lies in between 2 GR and 5 GR, then it covers quadrant of a circle and it will fall. It does not complete vertical circle, keep in mind. It does not complete vertical circle and it follows a parabolic path. Let us find tension. Okay, write this. Here I am using only two conditions, enough at least you remember these two conditions. If it is 3 GR, reaches up to here only. Yeah, completed this one. Just let me extend this. So, at C you got it as root 3 GR. Now I am rubbing everything. Let me write the velocities. At A root 5 gr, at B root gr, at C root 3 gr I am getting, okay. Let us suppose at any some place, if they are asking at any place. So let me find at this place, at anywhere, okay. If I start from this, actually derivation is very easy, okay, but I derived in a very easy manner. So let us suppose it will make something angle theta. Now the body is here, okay. Actually this is the original derivation, but okay, no problem. V1 at any point I am writing now, okay. I don't want to derive, just I will write. Weight of the body acts vertically downwards. If I extend, this is theta, what is this? Theta, and tension in the string is something T suffix theta. Velocity at this point, if I draw the tangent, this is V theta, and this is mg, you know well, this is what? Mg cos theta, and one more is acting m v theta square by r. Are you following? What is that m v theta square by r? What is that m v theta square by r? If I would have started from that equation, it is very easy, but okay, no problem. M v theta square by r is nothing but centrifugal force. Again you write T theta is balanced by these two. You take one equation, solve like how I followed earlier. Just you solve the same way, you will get V theta. So velocity at any point, this is A, B, C already taken. This is something P. At P, let me write directly V theta. Means you follow the same method how I followed earlier. Then you will get velocity at theta. You will get gr 3 plus 2 cos theta. You will get gr. Okay, after solving. Okay, after solving means follow the same process like total energy. Total energy at P, you balance with total energy at some other point, you will get the answer V theta. Okay. But I am writing a shortcut formula. So after solving, you will get this formula. Only formula I am writing. Up to V1, V2, V3 derivations are clear. Everything is clear. Now I am writing. If it is making some angle theta, then V theta you will get 3 gr 3 plus 2 cos theta. Let us check at A. At A, what is theta? 0. At A, theta is 0. This is shifted to A. Theta 0. Theta 0 means substitute here V1 gr. So keep, this is some shortcut formula. You feel that shortcut, okay? This is some shortcut. We can derive this also. Matter of few steps. Okay. Gr 3 plus 2 into cos 0 1. Then what is the answer? Tell me. Root 5 gr. Clear. Tell me at B, what is the theta value? Once the particle reaches the B, theta must be 180. If it is at A, theta 0. If it is reaches to B, theta 180. Theta 180, cos 180 minus 1. Then V2 gr 3 cos 180 minus 1. So 3 minus 2, nothing but what? Got the answer. At C, if they ask, at C, what is theta? 90. Why? See, A to C, how much is the angle covered by the particle? Particle body, okay. C is 90. From here to here is 90, okay. So cos 90, 0. So V2 is equals to, sorry, I have considered 3 now. So V3 is equals to gr 3 plus 0. Then what is the answer? See, getting the answers or not? So better you remember this formula to get the velocity at any point. If they given at this by making some 45 degrees, substitute 45. If they given 60 degrees, substitute 60. 120, if they given the point here, making something 120 degrees, substitute 120. Then you will get the answers. So V1, V2, V3. Better you remember this formula to get velocity at in every point. Velocity at every point. V1, V2, V3. Okay. So keep the formulas in mind. I told you already, these formulas are used to solve problems. So better you follow this shortcut formula. Possible, just matter of 2 to 3 steps. Take the free body diagram, T theta balanced by this one, you get one equation and extend it, you will get the answer. Simple mathematics, okay. So keep this formula as a shortcut and substitute theta value, just to change the theta, you will get the answers. Take this, keep all these complete topic as a note. Note means they never ask in the PUC board exams, but problems they may ask. Note, useful for entrances. Okay, I am covering very basics. If the particle leaves here, how much velocity? Okay, anyhow we got V1, V2, V3. Got this V1, V2, V3. Now let me find tension. Tension when the body is at A, tension when the body is at B, tension when the body is at C. Everywhere we can find the tension also, and of course there is a shortcut formula for tension also. Means by solving you will get the tension formulas. So let me find tension in the string. Tension in the string. Tension in the string. Anyhow we know what is the T1? T1 is mg plus mv1 square r. T1 mg plus mv1 square by r. So mg m, what is v1 square? 5gr by r gets cancelled, 6 mg. So what is the tension T1? 6 mg. And we know what is the tension T2? T2 is negligible. T2 above, T2 is negligible. If it is a T3, we can find T3 also. Okay. T2 is negligible. Then what is the difference between the tension? T1 minus T2 is how much? 6 mg. Otherwise, use one shortcut formula. So mg theta 0, so theta 0 means phi plus cos theta. Just let me check this shortcut now. 3 mg plus 3 mg 1 plus cos theta. Use this shortcut, 3 mg 1 plus cos theta. We can derive this also. Okay, I can derive this also in a matter of some steps. 3 mg 1 plus cos theta. Tell me at A what is theta? 0. Theta 0 means cos 0 1. Cos 0 1 means T1 is how much? 3 mg 1 plus 1. What is the answer? 6 mg. At B theta 180. Theta 180. T is equals to 3 mg 1 minus 1, which is equivalent to 0. Same. Downside. Is it visible? Yeah. So use this shortcut formula for a tension by making something angle theta. At C we can find the tension. Tell me, at C what is theta? 90. At C theta is 90. Theta 90 means substitute cos 90. So what is the answer? 3 mg. What is the tension differences at highest point and at C? 3 mg. 6 mg. Sorry, this is 0. 3 mg. From here to here, how much? 3 mg. Why? Because here 6 mg, here 3 mg. 3 mg. So keep the tension shortcut formula and velocity shortcut formula. So this is with what? Non-uniform speed. Okay, there are so many varieties based on this concept. We will see few. Completed? So at least you try to keep this formula in mind, v theta and t theta. Velocity at an angle theta, tension at an angle theta in non-uniform circular case. At least you remember these two formulas and try to apply formulas for different problems. Okay, this is the case when a body is moving in non-uniform speed along a vertical circle. If it is a uniform speed, we will get direct answers. Uniform speed. Uniform speed means just you take a bucket full of water. General things. Take a cup of tea, you rotate like this. It won't fall. The tea won't come out from the cup if you maintain a proper velocity. Okay, like in a circus, a bike will revolve in some globe with a constant speed. They will maintain some constant speed. Okay, velocity at each and every point will be same. In the same manner, take a bucket full of water, connect a wire and rotate in a vertical circle like this. Then velocity of the bucket at this point, velocity of the bucket at here, everywhere, if it is same, then water never come out from that bucket. If velocity is same, then water never come out from that bucket. Let us see how much velocity is required for that. Okay, let us find that also. Anyhow, non-uniform started now. Let me write one formula for a uniform speed. Finish this. Try to complete. Uniform speed. So I will wrap everything here, everywhere. Let me rub the diagram, complete diagram. Here diagram is clear. Draw the diagram. So let me write in a shortcut way directly. Here, this is the center and a body of mass m, weight of the body mg, t1 and v is the speed. Okay, v is the speed at every point. This is b. Here also the speed is v. Weight is mg, t2 and what is this? mv square by r. Here also mv square by r. R is the radius. Let us see what is the velocity and what is the tension at something point A, tension at P. We can find tension at other point also. See. Okay. See this. Again you follow the same method. At B, let me write directly. Let me write directly now. At B, tell me the equations. mv square by r out, mg, t2 is downside. So at B, t2 plus mg balanced by what? mv square by r. But what is t2? T2, tension is negligible at the highest point. Tension in the string is negligible because the wire never stretches. Once the body moves to the top, wire never stretches. So there is no tension developed in the wire. Okay, that's why T2 0. T2 0. So mg is equals to mv square by r. Then we got v is equal to what? Root gr. That. So this speed is required. Okay, this is the speed. So that the body moving with uniform speed along the vertical circle. If you maintain this speed for a bucket full of water, then water never come out from the bucket. If you rotate the cup of a tea in a vertical circle, then the tea never come out from the cup if you maintain V is equal to root gr. Okay, V is equal to root gr. If it less than root gr, it never complete vertical circle. If it is less than gr, it never complete vertical circle. So this is V is equal to gr. Let us find the tension. Substitute, see the at A, what is the formula? At A we can write T1 is equals to mg plus mv square by r. So T1 is equals to mg plus m by r. What is V? Gr. V is root gr, square gr. So how much it is now? Tension at the downward, T1 is 2 mg. T2 anyhow 0. What is the difference between the tensions? Difference between the tensions is 2 mg. So keep in mind, if the body moving with a non-uniform speed along the vertical circle, the difference between the tension is 6 mg, and with uniform speed, the difference between the tension is 2 mg. Okay? So there are two formulas. If a body moving in vertical circle with different speeds, then the tension in the string is, the difference between the tensions in the strings at the highest and lowest point is 6 mg in previous case. Here how much? 2 mg when body moves with a uniform speed. So keep in mind this also. Completed? Easy things. Some tough questions also there. If possible, I will try that also. So let me show you one good question. I think that will take some time. Okay, no problem. Is it over? I'll give you at least one good question today. This is nothing so far. See, one question at least, let me solve one good question. No, I am writing a question now. Please maintain the question. A mass m released from the top of a vertical circular track, from the top of a vertical circular track of radius r with a horizontal speed v0, with horizontal speed v0. Calculate the angle theta with respect to the vertical, where it leaves contact with the track as shown. So read the question twice at least. So let me draw the diagram and then you read once again. So let me draw. Yeah, they are given this diagram. Let me read the question. A mass m, see this is the mass m. Okay, so this is somewhat good question today now. A mass m, this is released from the top of a vertical circular track. See, this is the top of a vertical circular track. This is the vertical circular track, whose radius is mentioned r with the horizontal radius r with horizontal speed v0. So the given speed is V naught. Speed of the body is V naught. Then calculate the angle with vertical, angle theta with respect to the vertical, where it is going to leave the contact with the track. So very simple, just there is a body which is placed on this track, vertical circular track. If I given a velocity, maybe the body, if the speed is very high, maybe direct it will fall. If it is small, maybe it will come here and it will leave the contact. If it is very small, maybe it will come here, it will slide up to here, it will leave the contact. If it is more, it will directly leave the contact at this top point only. Let us give the name, this is A. So due to this velocity, anyhow they mentioned, it is going to leave the contact with the track. Means at some point it is going to leave the contact. So let me take at this point, this body is going to leave the contact. Means after that the body falls like this. Okay. So what they are asking with respect to horizontal or vertical? With the vertical. Okay, no problem. So it is going to leave here. Tell me, weight of the body will act at this point. What is the normal reaction force? So weight of the body, if I draw a weight, the weight of the body acts downwards, and what is this? Normal reaction force or not? Normal reaction force is perpendicular to the contact surface. And see, they mention with theta, what theta they given? So with the vertical. So let us take this is something theta, and if this is mg, what is this? Mg cos theta, and this is mg sin theta. No need of mg. Okay, mg sin theta. And see, the body covers this much height. Okay, let us suppose this is the height of the body. This is the height of the body. Observe the diagram. Height of the body. If this is height, what is this? H minus R? No. Complete is R. Complete is R. This we don't know. So then we will do one thing. Let us take the theta properly. So let me draw clear diagram. Okay, this is correct only right now, no need to worry. Let me extend this one. Correct everything, no need to worry. Yeah, this is normal reaction. Then it is clear. This is what? Mg cos theta, and this is R, this is theta, this is also theta. Okay, this is R. And this is H is equals to what is this? This value. Is it clear diagram? Shall I draw little big? I think it's, let me draw little big. Yeah, this is better so that you can understand easily. So here this is the block, and given a speed V naught, this is m, and here at any point it is going to leave the contact. Weight of this block acts vertically downwards. Let us take this angle is something theta. If this is theta, this is also theta. This is n, and this is mg cos theta and mg sin theta. And let us suppose this is the height h, this is r already given, and what is this? R minus h. Yeah, check it. R minus h. Now see, at this point, let us suppose if it is A and this is B, at B the body is going to leave. Okay. The body is going to leave. So what is the normal reaction here? N is balanced by, see, here N is balanced by, at this point the body will have some velocity. Okay, the body will have some velocity V. So some force is acting. What force is acting? What force is acting? Centrifugal force mv square by r. mv square by r. So at B, let me write directly. At B, n plus mv square by r is balanced by mg cos theta. But as the body leaves at B, then normal contact is 0. As the body is leaving means there is no contact here. Okay, before leaving it is almost, if the body leaves means normal reaction will be 0. So normal reaction 0 means what? mv square by, take smaller, mv square by r is equal to mg cos theta. So then what is v square? V square is equal to gr cos theta. Keep equation number 1. I got v square is equal to gr cos theta. Okay, then next you take the energy at here, you will get the answer. Okay, so apply the energy. Apply conservation of energy at A, at B. From law of conservation of energy, total energy at A is balanced by total energy at B. Let me do now, time is up. At A, at B. At A, there is a potential energy. See. And at B, what is the velocity? Okay, at B, only the velocity is V. So, potentially is here with what they are asking with respect to. So, at A, velocity is how much? V0. Height is r minus h. So, let me write and resolve the component also. This is r. What is h? R cos theta. This is r. This is r cos theta. H is equals to r cos theta. What is r minus h? R minus h. At A potential energy. At A potential energy mg r minus h. Kinetic energy half mv naught square. At B only this speed. So half mv square. Now let me write mg r minus h. R minus r cos theta. Why? Because h is equal to r cos theta from the diagram. Just observe the diagram now. Plus half m v naught square. Half m v square. M gets cancelled. This is gr 1 minus cos theta plus half v naught square half v square. What is v? Gr cos theta. Gr cos theta. So split up this one. So let me do first. Gr cos theta half v naught square half gr cos theta. Half gr cos theta, gr cos theta. So gr plus half v naught square is equals to gr cos theta. If I taken here 3gr cos theta. Okay, 3gr cos theta. Now target is to find out v naught. What speed you have to give? Theta they are asking now. So let me find theta. So cos theta we can write gr plus half v square by 3gr. They are asking at what angle. So theta is equals to cos inverse of gr by 3gr, 1 by 3, and this is gr cancelled. So v naught square by 6gr. Just let me check the answer somewhere, calculations. Verify the calculation here. I think I done some small mistake calculations. Gr half. Yeah, here this 2 comes here. Sorry, some calculation mistakes. Sorry. Let me do here. Multiply this 2gr. See, take LCM. 2gr minus 2gr cos theta plus v naught square whole divided by 2. Simple calculations, please try to verify the calculations. Gr cos theta, then 2 gets cancelled, so 2gr, take this 2gr cos theta right side, plus v naught square 3gr cos theta, so cos theta is equals to 2gr plus v naught square by 3gr. Check the calculations please. So theta is equals to cos inverse of 2 by 3, gr cancelled, and one more 2 by 3, and this is v naught square by 3gr. Verify this. See, initially, just listen for a minute. Here, the block of mass m, which is thrown with a speed v naught, so that after traveling some distance, it is going to leave the track. Let us suppose at b, it is going to leave the track. Okay, they are asking with what angle with the vertical the body is going to leave. They are asking this theta. So weight of this body is mg cos theta, and n. If the body leaves, here some centrifugal force will act mv square by r. Okay, now from this diagram I have taken n plus mv square by r is equal to mg cos theta, but at this point the body is leaving the vertical track, so n is 0. Then I got v square is gr cos theta. Okay, then I taken equation 1. Then I applied total energy at A, total energy at B. Total energy at A, total energy at B. So energy at A means this is the height, mg r minus h. What is this h? H is r cos theta. Why? Because this is r cos theta. H is r cos theta. R minus h, r minus r cos theta. So mg r minus h plus half mv naught square, which is equal to half mv square, because it is leaving half mv square. And do the simplification, you will get the answer. mgr r, okay, m cancel, gr 1 minus cos theta, half v naught square, half gr cos theta. V square is this one, from 1. Okay, and multiply this to 2gr into 1, 2gr into cos theta, 2gr cos theta plus v naught square whole divided by 2, 1 by 2 gr cos theta, 2 cancelled. Do the simplification, take this 2gr cos theta right side, it becomes 3gr cos theta. They are asking theta, so cos theta is equal to 2gr plus v naught square by 3gr. Theta is equals to cos inverse of 2 by 3 plus v naught square by 3gr. Okay, so many variety of questions are there. I will try to solve at the end. Okay, so almost this is one of the good question today. Okay, so I covered circular motion with non-uniform speed and uniform speed, vertical circular motion only. There is a horizontal circle and other also there. So please here you check the calculations. Okay, check the calculations and practice at least twice.